A new member has just joined our solar system. Astronomers have recently identified a previously unknown dwarf planet lurking in the distant reaches of our cosmic neighborhood. Named 2017 of 201, this mysterious object quickly drew attention due to its extremely unusual orbit. This calm, icy world takes an astonishing 25,000 years to complete a single orbit around the Sun. Even more intriguing, its path stretches from just beyond Pluto to a staggering 1,600 times the distance between Earth and the Sun. But that's not all. Its strange orbital tilt and movement could offer vital clues about a long-suspected missing member of our solar system, the elusive Planet 9. This discovery might finally bring us a step closer to confirming its existence. So, stick around to uncover what makes this find so exciting, and what it might reveal about the outermost reaches of our planetary system. For many of us, the solar system seems to end with Neptune. While the eighth planet is indeed the farthest known major planet, it doesn't actually mark the edge of our cosmic backyard. Contrary to what one might assume, far beyond the planetary orbits lies the Oort cloud, a theoretical region thought to be the source of long-period comets. While not quite as distant, but still far from Earth, is the Kuiper Belt, located about 30 astronomical units away. Just as a reminder, 1 astronomical unit, AU, equals the average distance between the Earth and the Sun, roughly 150 million kilometers. Like the Oort cloud, the Kuiper Belt is also considered a reservoir of comets and countless rocky bodies. In fact, it wasn't until the early 1990s that the Kuiper Belt's existence was confirmed, and it continues to puzzle scientists with its many unresolved mysteries. The reality is, we understand only a small fraction of these so-called trans-Neptunian objects. Yet, astronomers have already observed a curious trend. Evidence suggests that several of these distant celestial bodies tend to cluster in a specific region of the Kuiper Belt. The exact cause of this unusual pattern remains unclear, but some researchers suggest it could be explained by the presence of a fully developed planet roughly the size of Neptune. The existence of the mysterious Planet 9 is still a matter of intense debate among scientists. However, one thing is certain: researchers have now made a remarkable discovery in the outer regions of our solar system, one that could significantly influence the ongoing search for undiscovered planets. This breakthrough comes from a team led by Sihao Shang at the Institute for Advanced Study in Princeton. By closely analyzing data from a sky survey conducted with the dark energy camera on the Blanco telescope in Chile, the team identified a faint point of light that gradually shifted position between 2014 and 2018. According to the researchers, this movement strongly indicated the presence of a distant object following a highly elongated and eccentric orbit. Their theory gained further support when the same object appeared in archival images from another sky survey, this time carried out with the Canada-France-Hawaii telescope. This confirmed that the mysterious point of light was indeed a moving object, possibly linked to the Planet 9 hypothesis. From that point onward, it became evident that a massive trans-Neptunian object existed, one that had remained completely unknown to astronomers until then. A remarkable cousin of Pluto. But surprisingly, the discovery itself wasn't the most thrilling part of the story. The celestial body, officially designated 2011 KT-19, nicknamed in 2017, stands out for two key reasons. First, it's impressively large, about 700 kilometers in diameter. This makes it not only the second largest known object in this distant region of our solar system, but also, due to its consistent brightness, qualifies it as a dwarf planet. Scientists believe it earns this classification because it has enough mass for its gravity to shape it into a nearly spherical form. The second feature that makes this icy world so fascinating is its extreme orbit. At its farthest point, it drifts more than 1,600 times farther from the Sun than Earth, while its closest approach brings it to around 44.5 astronomical units, placing it near Pluto's orbit. To put that in perspective, it takes this dwarf planet a staggering 25,000 years to complete a single orbit around the Sun. What makes its discovery even more remarkable is the sheer luck and precision involved, because this object spends less than 1% of its orbit in a position visible to our telescopes. The researchers not only had sharp instincts but also caught it at just the right cosmic moment. The dwarf planet came into our view only because it recently passed its closest point to both the Sun and Earth. This event occurred in November 1930, the same year that the famous celestial body Pluto was discovered. Since then, not only have many decades passed, but the object known as 2011 of 2017 has been steadily drifting farther away. It's now approximately 90.5 astronomical units from Earth, making it one of the most distant objects in the solar system still visible in optical light. Although its visibility will gradually diminish over time, the discovery of this dwarf planet offers fascinating insights on a broader scale. For one, scientists believe there could be at least 100 similar-sized objects with extreme orbits located in the Kuiper Belt. Unfortunately, most of them remain undetectable due to their vast distance from Earth. Even more intriguing is the possibility that this dwarf planet could support the case for the existence of the mysterious Planet 9. While no direct evidence of this hidden planet exists, astronomers point to indirect clues, especially the unusual clustering of objects in the Kuiper Belt that share similarly tilted and elongated orbits. Could this alignment be caused by an unseen giant planet lurking in the far reaches of our solar system? Typically, the orbits of extreme trans-Neptunian objects cluster around an orientation of about 60 degrees. However, 2017 of 201 stands out as an exception. Its perihelion, the point closest to the Sun, lies at 306 degrees, which significantly deviates from the pattern observed in similar objects. This anomaly raises an important question: is 2017 of 201 even consistent with the Planet 9 hypothesis? If a hypothetical ninth planet does exist in the outer reaches of our solar system, why hasn't its gravity influenced the orbit of 2017 of 201 in the same way it seemingly affects others? This very question drove a team of researchers, led by Sihao Chang, to investigate further. Using simulation models, they explored how Planet 9 might interact with this unusual dwarf planet. Their findings were revealing. Without the influence of a ninth planet, 2017 of 201 would remain in a stable orbit for at least 1 billion years. But when Planet 9 is introduced into the model, its gravitational pull disturbs the dwarf planet's trajectory, drawing it too close to Neptune. This interaction sets up a scenario that ultimately leads to the ejection of 2017 of 201 from the solar system within roughly 100,000 years. In other words, the continued existence of 2017 of 201 seems incompatible with the presence of Planet 9. As a result, scientists now believe that the evidence supporting the existence of an undiscovered ninth planet is weaker than previously thought. While it's unlikely doesn't mean impossible. And if Planet 9 does indeed exist, scientists now have a fairly precise idea of where it's most likely to be found. That's the conclusion reached by Mike Brown and Konstantin Batygin from the California Institute of Technology, who explored a variety of scenarios using advanced models and simulations. They tested different masses and sizes for the potential planet, factoring in more than just gravitational influences from the known planets. Their aim was to pinpoint an orbit that could best explain the unusual movements of 11 distant trans-Neptunian objects, bodies with wide, tilted orbits. Their research produced a sky map that significantly narrowed down the area where Planet 9 might be hiding. If the planet resembles Neptune and has around 6 times the mass of Earth, its orbit would have a semi-major axis of about 380 astronomical units. Based on this, it would swing as close as $300 and as far as $450 from the Sun during its long journey through space.